Hi, my name is Tom Perdue. I'm the Product Development Manager for Cambridge International. We're a division of Regal Rexnord. Cambridge designs and manufactures conveyor belts, mainly for food and industrial applications. Today I'm standing in our test facility here at Cambridge, and I would like to introduce you to one of our newest products, KleanTop PacTitan Pro. So why did we develop this? Well, we've known for some time that many of the existing belts in the food processing applications often have very short service life, a few weeks or possibly even a few days, and we just want to accept that as an outcome because we were certain that we could do better. We know that existing belts often can be difficult to work with, difficult to splice, difficult to take apart and put back together. And we also know that there was a risk with the existing belts of having broken components to get down into the product. This can involve product recalls and rework of the product itself. So this is our PacTitan Pro. It's a very simple construction, just two components, a flat strip that's formed into a picket and a wire for connecting those pickets together. The strip is just standard stainless T304, very common in the food industry. The wire is a 302, stainless, very similar in makeup as 304, but allows us to have a higher tensile strength of the rod, and that's important for the longevity of the belt. Our PacTitan Pro is fully customizable, varying widths and number of openings and size of openings to address the needs of many different applications within food processing. And these applications can include frying, glazing, battering, forming, breading, and even just light transfer conveyors. So there are a number of interesting features within this belt. Let me show them to you and describe them. The first is this belt has dedicated sprocket lanes. Openings across the width of the belt where we would locate sprockets, narrow openings where we reduce the amount of bending and distortion within the belt as it engages the sprocket. That's important for belt life. We have variable infill patterns. The openings between the sprocket lanes, here we show a triple infill. We can do a single infill, we can do different number of openings, and so on and so forth. The picket is formed with some special internal bends that allow this belt to more fully articulate. We know that the existing belts in the field often fail from fatigue, and that's a result of the belt not fully articulating, but instead flexing and bending as it articulates, and that causes the early failure of the belt due to fatigue. The belt comes with interlocking edge, and that provides a very safe edge for the belt, and it reduces the chances for the belt as it's moving to snag the clothing of operators that are nearby. If and when the belt breaks, we've designed this so it'll stay together. Here I've shown a broken part of this belt, and you can see as long as there remains one closed hole in that picket, that part doesn't drop out, and it's very, very effective as a means to prevent product contamination, metal components within the product itself. The belt is reversible. You should find in certain applications where you're developing patterns, wear patterns on the belt, either the top or the bottom. It's a fairly simple matter of just reversing the belt. And finally, the key part of this thing that we think is the ease of splice. Just with a few simple hand tools, it's rather easy to just remove the rod. The rods are reusable. All the pitches are the same. There are no dedicated splice joints within the belt. Basically, we've created a metal belt that requires no welding or clinching to assemble. That ease of splice translates into a reduced time for the splice, just a few minutes rather than perhaps 15, 20 minutes or longer, as is typical for some of the standard belts that we're looking to replace with this thing. So today I'd like to show you how easy this belt is to splice, and we're going to show that on this conveyor behind me. So this is our KleanTop PacTitan Pro belt we fitted on one of our test conveyors here in our lab. And I want to show you just how we would take it apart and put it back together just using some simple hand tools. In this case, I have a small flat blade screwdriver and a pair of needle nose, which I may or may not need for this demonstration today. So to start take the belt apart, you'll need to have some slack in it. We've already taken that step here for this video. And come to any of the pitches with a screwdriver. Insert the blade between the end of the rod and the picket, and just rotate it a few times to move the rod out. It may take a few turns, and as you do that, you'll eventually get an end of the rod that's protruding. With the pliers, you can take that and just pull it out, and basically separate the belt by removing the rod completely from it. So now I've separated the belt. I can add pitches, take pitches out, repair the belt, and so on. And to put it back, you just basically taking the same step, inserting the rod back into the belt. Again, the rod is fully reusable. Any rod will work on any of the pitches. And as long as the belt is lined up, it's be helpful to have it nice and flat when it goes together, so the pickets are in alignment. And if you get the holes started, you just feed the rod through carefully, so you hit all the openings, and you can follow it across the width all the way. Until you push in as far as you can. And the last step is just to take the screwdriver or something small and push the end of that rod in fully until it seats. And it's finished. Obviously here, I had the advantage of being able to work the rod through an opening in the conveyor. You may have that, you may not. If you don't, it might become necessary to actually lift the belt slightly above the surface, the edge of the conveyor, to have that opening to be able to move the rod in and out of the belt. Very simple, very easy, and very quick, as I've shown. And this belt's 34 inches wide. That's a standard width for a belt in a lot of food processing applications. So it's no more difficult than that. Try it. I think you'll like it. Thanks.